Hello friends, welcome back to the new tutorial of the Angular. Today we are going to learn about the signals in Angular. Those who haven't subscribed my channel yet, please do subscribe my channel, and if you like the video, please do like, share and comment on my video. Let's get started. In Angular, it is introduced in Angular v16. It presents a reactive programming feature designed to manage the state and the data flow. A signal is a special type of reactive primitive that encapsulates a piece of state and ensures that when the state changes, any associated computations or the updates are automatically triggered. They are inspired by the reactive programming paradigms commonly seen in the frameworks like reactivity in the Vue, Servlet. Signals allow developers to define the state reactively, trigger automatically updates when the state changes, avoid manual change detection in many scenarios. Key concepts of the signals like signal creation, signal read, signal write, computed signals, and the effects. These are the main core concepts. Signal creation, signals are created using the signal function and store a value. You can read and update the signal's value using the getter and the setter functions. Signal read. To access the value of the signal, you can use the getter functions. To signal write, you can get the setter function. To update the value of a signal, you can use the setter. Computed signals, these are the derived values based on one or more signals. They automatically update when the underlying signals change. Computed signals, okay? Effects allow you to perform the side effects when the signal changes. Let's go with the code level. Explain use example of using signals in the Angular. Let's have a look. Okay, so here you can see that we have an app signal demo. I'm going to use in our app component main. So let's copy this template and let's go to the app component. Let's go and where is template part? Template URL. Okay, so here we have the functions that we need to define. So let's define a signal. With decrement we have to go with this. Okay, I hope all the issues resolved. I think we have to declare use this one. Okay, so Angular core we have to go with component, signal computed, and the effect. So let's import all of these from this. Okay, now done. Okay, so the first here we have signal 0. Okay, creates a signal counter initialized to 0. Here you can see that. So here you can see that define a signal, right? So creates a signal counter initialized to 0. This dot counter reads the value. So here we have this dot counter, right, which will do the reading the value. This dot counter, what it will do, reads the value, and this dot counter dot set updates the value when we have the set is the setter function. And what will it will do, it will just set or update the value, right? Next, computed creates a derived signal double counter that depends on the counter. Okay, so here you can see that we have the computed value, right? So it's just doing the double. Okay, so the computation part is done in this computed signal. Creates a derived signal double counter that depends on the counter, automatically updates whenever the counter changes, obviously because it is a computed. So whenever there is a change in the counter, it will automatically update and give you the data. Effect, define a side effect that runs whenever counter changes. So whenever there is a change in the counter, it will log that one. So logs the updated counter the value to the console. So in the effect here, whenever there is a change, it will log the value. Okay, in the effect, right? So the template displays the counter and the double counter values, provides the button to the increment and the decrement counter. Benefits of the signals, let's take a look, and real world scenarios. Okay, so here we have, so the first one, that is benefits of signals, is fine grain reactivity. Signals update the only the components affected by the state change, improving performance. Simplified change detection, Angular zone based change detection can be avoided in many cases, reducing overhead. Readable code, signals provide a clear and declarative way to define and react to the state changes. Integration with RJX, a signals can complement or integrated with the RxJS for more advanced use cases. Real world scenario, imagine a shopping cart in e-commerce application. a signal holds the card items. A computed signal calculation like the total price. Effects can be used to update the server or the local storage whenever the card changes. So this is a real world scenario. Let's take a look because we have already done this one, and let's go with our code. Okay, so here we have the localhost. Open that link. Cannot find the name signal. Where? Okay, reload it. Now F12. Okay, counter change to 0 because we have logged into the effect. Okay, so it logs. Increment, counter change to 1, again log. Okay, double, counter change to 2, double. The computation done. Okay, so it's double every time. Increment, it's 6, the log. So whenever there is a change in any kind of signal, so where it comes in? Effect. So in effect, it logs that one. Okay, fine. And decrement, you can see that the counter change to this. So this is how the signal works. This is a simple example. Now we have to do with the cart items also, because you will get the more clarity on that. Okay, any doubt, any query in that, do let me in the comment section. Thank you so much for watching this video. Have a great day.